Hello everyone, welcome back to my daily coding series. Today's day 67. So I'm just going to pick a problem somewhat at random. We could do subarray sum equals k. I have not read this problem before. So the goal is I'm going to try to do it in 20 minutes. I'll go up to 30 minutes before stopping. I will do all my problem solving on the document instead of using Paint to mimic an interview setting. A couple goals for today is I want to be a little aggressive with my assumptions. I want to solve the general case before worrying about edge cases too much, and I don't want to over optimize too quickly. So that being said, let's read this problem and give it a try. So given an array of integers nums and an integer k, return the total number of subarrays whose sum equals k. Okay, a subarray is a contiguous non-empty sequence of elements. Okay, so here we have two subarrays, and here we have two subarrays. Okay, so what comes to mind is a brute force approach would be to generate all subarrays, and then if sorry, I had to sneeze. If the sum of subarray equals k, then result would go up by 1, where result is the count. Yeah, so that would be the brute force approach to this. Can we think of a better approach? Does everything have to be positive? No, they can be negative. So I'm thinking we might get some utility from sorting. Because if we sort, then we know that if we continue, the number will be bigger than the last one, which is not guaranteed. Because there are negative numbers. So like in the example 1, 2, 3, where k equals 3. So it could be also like 3, 1, 2. There could be like a negative 2 in there. K could also be negative itself. So my question is there a better way to do this besides like, do you have to generate all of them, or is there an easier way to do it? So something that comes to mind is if we have 3 in our subarray, then we know that the remainder of the subarray has to add up to k minus 3. Yeah, okay. So subarrays are, so we can't sort it actually because that would mess up the order, but we need to maintain the order of the subarrays. So we cannot sort. So I'll just note cannot sort because we need to maintain order. So we could do is just keep like, so we know 3, so let's say k equals 5. So in this case, the answer would actually be 0. But the reason I'm thinking is it would be 3 plus, does the rest equal k minus 3? Which is 2. So can we get a subarray that here that equals 2? So 1, 2, negative 2. And we can't skip 1. So we'd have to say, so maybe we could just keep adding them until we either hit the target or go over the target. Or, yeah, if we go under, well, if we go over, that's fine. So this would be, so to generate all subarrays in this case, so if we have 1, 2, 3, all the subarrays would be 1, 1, 2, 1, 2, 3, 2, 2, 3, and 3. So this looks like n squared behavior. So a way that we could do that is starting at every character, we can just yeah, so it's tricky with the negatives because we can't even really stop if we go over, because if we have, let's say 1, 2, 3, negative 3, k equals 3, like this. So there's 1, so we'd say, okay, 1 plus 2, so that's 1 subarray where it equals, and then we would actually just keep going and say, okay, now we're at 6, and now we're at 3 again, so that's another subarray. Yeah, and then you would do it from 2, because, well, is there any inference we can gain on the first pass? Well, yeah, we would need to do it again from all of them, unless we checked. Okay, so I'm thinking we would need to do it again from all of them because we need to find that 3 by itself is a subarray, unless we could determine like the total sum so far minus the sum of just the one that we passed. So maybe we can think like, so the total sum so far is 1, and if we don't include 1, it's 0. Well, that would still be n squared. So we could have 1, and then here the total is 3. So the total means everything up until this point. So I'm wondering if we could use like prefix and like postfix sums maybe somehow to identify if we ever, so maybe we could do, let me try doing so a prefix sum would be like this, right? So that's like the prefix sum, and the postfix sum, which is basically summing up all the numbers from this way. So I'm just going to initialize all these to 0. So it'd be negative 3, 0, 2, 3. And then our answer would be, I'm not sure how this helps. I was thinking because 6, in the prefix sum, because 6 minus the rest is 3, then we know that this by itself, we've only added 3. So what if we had 1, 2, 3, what if we had 1, 2, 1, 2, negative 3? So the prefix sum would be 1, 3, 4, 6, 3. So is there a way that we could identify that from here to here we added 3? So maybe we can look, so if we turn this into a prefix sum, now we can look for all distances, or like all differences of 3, and that would be our answer. So, and then of course there's like an implied 0 at the beginning. So from the start to 3 is 1, and then from 6 to 3 is another, and then from 3 to 0 is another one, but also 4 to 1. So if we could somehow find all of the distances of 3 in O of n time, then we could do one pass through for the prefix. So this would be our array. We'd pass through it to get the prefix sum. And then maybe we could just find all of the distances in 3. So like, which of these, when you subtract them, have a difference of 3? And that seems like, okay, so that'll be our new problem that we're trying to solve, is can we figure out all distances of k in O of n time? So how would I do that in O of 1? Well, maybe what we could do is store, like almost like how you solve two sums. So we'd have like a dictionary, and we would say, so we'd have a dictionary, and then when we'd encounter 0, then we'd say, okay, so 0 needs 3. So if we find a 3, then we know that we have a distance of 3. And then for 1, we'll say, well, 1 needs a 4. And then 3 will say, okay, we found 3. We might not even need to store the keys here, but let's just, okay, so we found 3. So that means our result plus equals 1. And then we'll store, well, 3 needs a 6. Then we encounter 4, and we say, okay, we found a 4, so our result goes up by 1. So our result is 2 now. And then 4, we would store 7. And then we find 6, so the result would go up by 1. And then we would add 6 goes to 9. And then we find 3. So we can keep this in here, because if we find multiple of these numbers, then it means that there's multiple subarrays. So this would count again. So this would give us 4, and then we'd say that 3 goes to 6, which we already have. Yeah, so we might not need that 0 there, but we can just initialize in our dictionary. So 0 to k in our dictionary. So is this answer correct? 4. So let's think. So this is our prefix sum, but the example that I had was, I think it was 1, 2, 1, 2, negative 3, correct? So 1, 2, add 1, add 2. Yeah, okay. So here, the sub arrays that sum up to 3. So we're at 13 minutes. So that would be this one sums up to 3. This one sums up to 3. This one sums up to 3, and this one sums up to 3, right? So let me do that again. So the whole thing sums up to 3, because this is 3, 6 minus 3, which is 3. This sums up to 3, because 1 plus 2. Well, this sums up to 3 also, actually. And then this sums up to 3. So that's, okay, so we have 1, 2, 3. And then we have 4, 5. So I think the answer is 5. So I wonder if there's a reason why I missed this one right here. So let me try again. So we'll initialize, so instead of a dictionary, I'll just have a set, I guess, which stores the values that we need. So we initialize 3 in our set. So I'll just keep it like this for now. Okay, then we encounter 1. So that means we add 4 to our set. Then we encounter 3. So our result becomes 1. So what this 3 signifies is that so far we have a running sum of 3. So that's the first subarray that it just found. Then we have a 4. So 4 is in our set. So we add 1 to it. Okay. I'm thinking maybe we need to store like counts of like how many subarrays this would fulfill, perhaps. So, okay. So result is at 2. We were at we just encountered the 4, right? We just encountered the 4. So 4 should add 7. Let me just add a pointer here. So, okay, so we're at there. And then 4 fulfilled. So what does this 4 signify? Well, it means from 1 to 4, there's been a subarray. So that's this one. Now when we go to 6, that should add 9. That should add 9. And 6, okay, I didn't add 6, so 6 should have been in here. Okay. I'm going to restart and not get sidetracked this time. So we initialize 3 in our set. Okay, so we encounter 1. So that's not in our set, so we don't increase results. But we add 1 plus k, which is 4. Now we continue. 3 is in our set, so we add result by 1. And then we're going to add 3 plus k, which is 6. Then we increase I. 4 is in our set, so we increase result by 2. And then we add, so 6 was in there, so now we're adding 7. Okay. And then I goes up by 1. 6 is in here, so we're going to add result by 1. And then add 9. And then 3 is in here, so we're going to add 1. And then, okay, so that's the problem, is that right here when we encounter this 3, it should actually get us 2. So should this 6 add 3 to it as well? You know what I mean? Like, because the sum dropped by 3. So instead of adding 9, does it also make sense if we encounter 3 again? So do we go in 2 directions? Like, do we add like number plus k and number minus k? So what does that conceptually mean? So when I'm saying 1, we need to find a 4 in our prefix sum. What does that mean? It means that we will have added 3. What if we find a negative 2 in our prefix sum? Or I guess, yeah, a negative 3, I guess. No, negative 2. If we find a negative 2, so what's an example where we'd find negative 2? So if we have 1, negative 1, negative 2, let's say like 3. So the prefix sum of this, so I'm wondering, so this didn't work because this one actually should find us 2, it should find us 2 subarrays that work, but it only finds us 1 because, so just to recap, when we have I equals here, there's no subarray that equals 3. When I goes here, we see that we found a target 3. When I goes here, we found a target 4. When I goes here, we found a target 6 from this 3. When I goes here, so it should really be, so when I goes here, we find just the target 0 at the beginning, but we should also be finding that in our example, this is also, wait, this adds to 0. So maybe I'm just wrong. This does not add to 6. So maybe this is right, because this, so I think I mistakenly identified this as a subarray that equals k when it actually equals 0. This one, however, does equal 3. So I think this is not even an answer, so that means this is correct. So I'm going to delete this. Okay, so before I code this, I'm going to, so we're at 20 minutes exactly, so I'm going to try to code it soon. So I'm just going to walk through these examples here. So 1, 1, 1, k equals 2. So I'm going to generate the prefix sum like that. And now I'm going to have our set. Okay, so I is here. So we're going to add 4. Wait, what's k? 2. Okay, so we're going to add 3. Well, also we have to initialize 2 in our set. So this is our set. So 1 is not 2, so then we're going to add 3 and move it on. Okay, so 2 is in our set, so we'll say result plus equals 1, and then we'll add 4 to our set. And then when we encounter 3, 3 is in our set, so we'll add it, and then we'll add 5 to our set, and then I goes out of bounds, and our result is 2. Okay, next question. So that one works. So I'll say example 1 and example 2. So now we have 1, 2, 3 with k equals 3. So the prefix sum of that would be 1, 3, 5, right? Because this sums to 3 and this, well, this should be 6 actually, yeah. Okay, and then k equals, well, we don't need to know. All right, and then we'll have our pointers, and then we'll have our set. So our set gets initialized to just k, which is 3. Okay, so 1 is not in our set, so we're going to add 4 because that's 1 plus k. 3 is in our set, so we'll say results equals 1. And then we'll add 6 to our set, and then we encounter 6, and we say that 6 is in our set, so we'll add 1 to it. Okay, so it looks good. So I'm going to start coding that. So we just need 4 num in nums, and we'll have a set which equals, so I'll call it needed, so like what we need, and I will just put in k. So first of all, we'll check first we have to generate the prefix sum actually. So prefix sum, and then, okay, so so we'll say so it's just the last number in the array plus, so we'll initialize it to 0 times length of nums. So we'll make an array prefix sum. So we'll say prefix sum of I'll just use enumerate here. So we'll say prefix sum of I equals prefix sum of so I'm going to change it to a while loop. While I is actually for I in range. Okay, so I'm going to initialize prefix sum of 0 to just be nums of 0. And then we'll say in range 1 to length of nums like this. So this can wait. So we're just going to generate prefix sum. So prefix sum of I equals the previous one plus my number, so nums of I, and I think that's it. So this should give us the prefix sum. So just to make sure, I'm going to print that out real quick before I go to the next section, just to make sure our prefix sum isn't giving us any errors here. All right, still not muted. Okay, 1, 2, 3, that's correct. 1, 3, 6. Okay, so this is working. Perfect. So now what we're going to do is initialize needed to be k. So this is our set, and then we'll say for num in prefix sum. So we'll keep that there. Use prefix sum to find subarrays. Okay. So the idea was we check, is this number in k? So if num in needed, which is O of 1 lookup, then we'll say result plus equals 1. So we'll set result to 0. So if it's in there, we will just add the result, and regardless of whether it's in there or not, we will say needed dot add num plus k. Right, and then we can return results. So let's try that. See if I'm missing anything. It seems to work. And wrong answer. Okay, so let's see here. So we have 1, -1, 0, k equals 0. Okay, so the expected value is 3. So maybe I misunderstand the problem, because I see that this one adds up to 0, and I see that this adds up to 0, but I don't see a third subarray that adds up to 0, because there's only 3 subarrays. There's this one, and this one, and this one does not. So maybe I misunderstand the problem. Who equals k? So does contiguous, where was I looking at? Wrong answer. All right, so this signifies to me, so I'm at 27 minutes, that I have a misunderstanding of the problem. So 1, oh, no, I don't have a misunderstanding of the problem. So this, okay. This is a subarray that equals 0. This is a subarray that equals 0. And this is a subarray that equals 0. So let me do the algorithm. So the prefix sum would be 1, 0, 0. And then we would start I here, and we'd set our set equal to just having 0 in it. So we'll say, okay, so this is not in our set, so we'll add 1 plus 0. Then we will go here, and we will say that's in there, so our result goes to 1. And then we will add what? We'll add 0 plus 0. And then when we encounter it again, okay. So actually what we want to do is, so I did say this earlier. So here it's only going to add 1, but we really want it to add 2. So I think instead of needed, we'll have a dictionary, and then we'll say, so the value, and then how many subarrays that completes. So what we should say is, if it's in there, then we'll add it. And then we'll say, if it's in there, what we want to do is result plus equals by d of num, like this. So add by this number instead. And then what we want to say is, instead of adding it to the dictionary, we want to say, if num plus k not in dictionary, then we'll say dictionary of num plus k equals 0. And then instead of adding it, we'll say d of num plus k plus equals 1. So we'll always add the count to it. And then if it's not in it, we'll just make it 0. Yeah, so let's try this. So I've attempted too soon. So I wanted to use this as a test case. My code, I can't see my code. All right, there it is. So hopefully that was it. Yeah, so that fixed that one. So I did have this intuition earlier. Okay, sweet. So let me delete all of this. It looks like my solution's really slow. Unfortunately, but d of num. I'm not printing anything, right? Yeah. Okay. So I'll submit it again. It looks like this one's pretty slow. Yeah. It's still linear though. But maybe I don't have to do 2 pass-throughs. But yeah, anyway, so that's today's episode. We're at 30 minutes. So thank you guys for watching, and I'll see you tomorrow for day 68.